Alright, so in this video, we want to look at an interesting topic in physics that we call dimension. We call it dimension, okay, or we can call it dimensional analysis. Dimensional analysis, okay. Now, before we can understand this dimension or dimensional analysis very well in physics, we must know what we call the fundamental quantities. Fundamental quantities are the quantities on which this aspect of physics is what now is based. We can equally say they are the building block of dimension. Fundamental quantities, I repeat, are the building block of what of dimension. So, if you want to have a solid understanding of dimension, we must know what we call the fundamental quantities. So I'm going to give us a table, okay, that will show the fundamental quantities that we have in physics. Then before we proceed to what we call dimension. So we have 7 of them in physics. Okay, so let us go like this. Let's have this table. Fundamental quantity, fundamental quantity. Okay. Now, the first one is what we call the mass. Call it mass. Second one is what we call the length. The length. Third one is the time. Then the fourth one is what we call the current. Then the fifth one is what we call the temperature. The sixth one is what we call amount of substance. Okay, are you with me, class? Amount of substance. Now, the seventh one, which is the last one, is what we call luminous intensity. So, what are the units? The SI unit. The SI unit of what now? Or these fundamental quantities that we have in physics. The first one, the unit of mass is kilogram. The unit of mass is kilogram. Okay. The unit of length is meter. The unit of time is second. Okay. The unit of current is ampere. The unit of temperature is Kelvin. The unit of amount of substance is mole. While the last one, the unit of intensity is what we call candela. Okay. Now, after this, we must know their symbol. Because it's on this their symbol that dimension will work now. We go back from. Okay, we must know the symbol of all this work now. Their SI units. Now let's go to symbol. We can call it symbol, or we call it what now? Abbreviation. Symbol one you want to call it abbreviation. Okay. Now, what is the symbol for kilogram? Which is the what now? Which is the what now? Mass. It is kg. The symbol for meter, which is the unit of what? Length, is small n. The symbol for second, which is the unit of time, is small s. The symbol for ampere, which is the unit of what? Current, is capital what? Capital letter A. The symbol for Kelvin, which is the unit of temperature, is capital letter K. The symbol for mole, which is the unit of what? Amount of substance, is MOL. Okay, so can use MOL, so can use what? Small letter N. So can use MOL or small letter what? N. Are you with me? Now, the symbol for candela, which is the unit of luminous intensity, is CD. Now, what is now their dimensional formula? Let's write now, that dimensional formula. Okay? Dimensional formula. Now, anywhere you see this kg, which is symbol for what now? For mass, we change to capital letter what? M. Anywhere you see this small word, this small n, which is the what now? Symbol for length, to the capital letter what? L. Anywhere we see this second, which is symbol for what? For time, becomes capital letter T. Anywhere we see this A, are you with me? Which is what now? Symbol for current, we use this. I. Anywhere we see this scale, which is symbol for what now? Temperature. We use this symbol. Then anywhere we see mole, which symbol for what? Amount of substance. We use capital letter N. Then anywhere we see CD, which is symbol for luminous intensity, we use capital letter what now? J. So these are the what now? The dimensional formula, okay, or these abbreviated what now? Symbol. Are you with me? Now, it never implies that the dimension of a physical quantity can be expressed mathematically as class. Look at this. So if I say dimension of a physical quantity Q can be expressed mathematically as from this half A n raised to the power A, I have L raised to the power B, I have T raised to the power C, I have I raised to the power D, I have theta raised to the power E, I have N raised to the power F, and I have J raised to the power what now? G. J raised to the power G. So it implies, pay attention to this one, because we are going to understand all these hidden things under dimension. Dimension is very interesting. Once you pay attention to the way I'm going to work now, explain, okay? And look at this. So, what we're saying in essence is this: dimension of physical quantity can be in this form, this form. It does not mean that all of them must appear. We can have 2 of them to appear, we can have 3 of them to appear, we can have 4 of them to appear, but it's not a must that all of them should appear. So, what are these things? A, B, C, D, E, F, G. They are what we call dimensional powers. Okay, we call them what? Dimensional powers. So where A, B, C, D, E, F, G are dimensional powers. Dimensional powers. Dimensional powers. I can call them powers. I can call them index. Okay, I can call them what now? Exponents. So when you remember the word pi, P-I-E, pi. P-I-E. P is for power, I is for index, E is for what now? Exponent. So all these things we call them dimensional what now? Power. You with me? So let us define dimension now. Based on what I've explained, what is dimension? Because dimensions of a physical quantity are the powers, okay, to which this unit can be expressed to represent the what now? Physical quantity. Are you with me? I recap. The powers. So when they say what is dimension? What is dimension? Let's define dimension. Dimension is just what now? Dimension of a physical quantity. Dimension of a physical quantity. Of a physical quantities. Okay. Are the powers. To which the fundamental units. Fundamental units of what now? E.g., we can have what? Our mass. Okay, we can have our length. We can have our time. etc. Okay, the powers for which all these must be raised to what? To represent the quantity. That's all. So this is what we call dimension. Although they won't ask us that we should define dimension, but we're going to use all these things that are written here, okay, to solve questions under what now? Dimension. So what is dimension again? Dimensions of a physical quantity are the powers to which the fundamental units of mass, length, time, etc. must be raised to represent the quantity. So our concern under dimension are the powers. Are you with me? So our major concern under dimension are what now? Are the powers. After we memorized all this dimensional formula, are you with me? So let us take questions. Questions to buttress our facts under this dimension. Let's take the first one. You see question like this. What is the dimension of velocity? What is the dimension of velocity? Now, class, The first thing you must know is units. To solve a question of another dimension, you must know the unit of that quantity whose dimension is to be what now? Obtained. Are you with me? So they ask us for the dimension of what now? Of velocity. Let me wipe this one off. Let me wipe this one off. What is the dimension of velocity? Dimension of velocity. So let's go. So we need this. We won't clean this. Okay? We need this. We will not clean this. Alright, so what is the unit of velocity? The quantity first is what? Is velocity. Like I said, if I want to solve question under dimension, I must know the unit. So I will have to say first, what is the unit of what? Of velocity. Velocity is measured in what now? In meter per second. Velocity is measured in meter per what? Per second. So what is the dimensional formula? Or just the dimension of velocity? So we have, anytime I see small m, we change to what now? L. So I have L. Now, anytime I see small s, change to what now? T. So I have T, this one what now? Minus 1. Now look at this. It can be written like this. Okay, or I can write like this word now. M raised to power 0, L raised to power 1, then T raised to power what now? Minus 4. So what are the powers? What are the powers? 0, 1, and minus 1. It can be written like this. Or some questions, you won't see this, you will see this form. So it means the power of m is 0. That is why it is missing here. Anything raised to power 0 is 1. That is why m is missing here. Okay? I must express my dimension in form of what now? MLT. But here I have LT raised to power minus 1. What is the power of this L? It is 1. Under one of the laws of indices, if I have A raised to power 1, it will give us what now? A. Anything raised to power 1 will give us that thing. That's why this L here is the same as what now? L raised to power 1. So I can have it like this, or I have it like this. So wait, that's what are the powers, okay, of this dimension? 0, 1, and minus 1. Are you with me? So what is the most important thing I can under dimension? We must know the units of that physical work now. Quantity. Another example, this question 1. Question 1. Q1. So Q2. They ask us for the dimension of what now? Of acceleration. Okay? Dimension of acceleration. So we have acceleration. What is the quantity? The quantity is what now? Acceleration. What? Acceleration. The next thing is, what is the unit of acceleration? Okay? Acceleration is given what now? Meters per second what now? Square. Meters per second square. So what now is the dimensional formula? Dimensional formula or the dimension. That will give us M, see it? We have L, okay, T, this power now, minus 2. Okay, so correct. So it can be like this, or I can do this one. Our M is missing because it has power of what? Is 0. So M is power 0. This L will have power of 1. So I have L is power of 1. Then this T will have power of what now? Minus 2. So what are the what? What are the power? 0, 1, and what now? And minus 2 for acceleration. Now, class, let us go beyond velocity and what now? Acceleration. Okay? We know velocity, we know acceleration. What about what we call jerk, snap, pull, crackle? Now, look at this. This brings us to an interesting aspect under what now? Under dimension. Okay. Now, we know the unit of what now? Velocity is what now? Meter per second. We know the unit of acceleration is what now? Meter per second cube. What about meter per second cube? Okay? Meter per second is per what now? 4. This is per 5. This is per 6. Look at this. Let me just give us what? The table. I'm just going to wipe this one off. Okay? You can just watch the video over. Okay? And if you are enjoying this video so far, please subscribe to our YouTube channel. Okay? Just press the red subscribe button and turn on the notification bell. So when we release amazing videos like this, you get notified that a good and comprehensive lecture has been now released. Okay, just press the red subscribe button and turn on the notification bell. So I have this. I have position. If I have S like this, S means position or distance. Okay. Now, if I differentiate this thing, the x over the t, okay, the x over the t is the first derivative of what? Of position. Now, this trend is what now? In meter. So let us go. What's the unit of this position? Unit is what now? Is meter. M meter. Meter. M. Are you with me? So x is what now? Meter. The first derivative of x is the x over the t. That rate of change of position is what we call velocity. Velocity. Which we've done. What is the unit of velocity? Meter per second. Are you with me? So what is the dimension of meter per second? We've done that. What do we have there? Dimensional formula. Dimensional formula will give us what now? Plus. Page the page between. This will give us what now? L T raised to what now? Minus 1 for velocity. Now, this is the first derivative. First derivative. What about the second derivative? Meaning our d square x all over the t square. When we differentiate this function twice, we have what we call acceleration. Acceleration. Now, what is the unit of acceleration? Meters per second what now? Square. What is the dimensional formula? L t raised to power what now? Minus 3. If I differentiate this thing 3 times, I have the cube x all over the t what now? Square. When I differentiate position 3 times, or I differentiate acceleration, are you with me? I will have what we call J. What we call what now? J. What's the unit of J? Meters per second what? Cube. Are you with me? It does not stop at meter per second square only. I will give you 2 meter per second power 6. Are you with me now? So for this, what is the dimension of J? It is L t raised to power now minus 3. If I do the fourth one, the fourth s all over the t raised to power 4. So now the fourth derivative is what we call snap. Snap. Okay. Now what is the unit of snap? It is meters per second raised to power now power 4. What is the dimension? L t raised to power now minus 4. Now look at this. This is what now? T raised to power 3, not 2. This is the third derivative. This is the fourth one. This is second derivative. This is the third derivative. This is what now? Fourth derivative. So let us move to the fifth and the sixth one. So the fifth derivative, we have the fifth x all over the t raised to power now 5. This one is what we call cracking. 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 Okay? What is the unit of what now? Cracking. Meters per second raised to power now 5. What will be the dimensional formula? L t raised to power now. Sorry. And the last one is what we call pour. Call it pour. Pour. What's the unit? L raised to power minus 6. And what's the dimensional interpretation? We have L t raised to power now minus 6. So this is the what now? The sixth derivative of position. Okay? So we have the 6x all over the t raised to power now 6. So you can master all these. Okay? Because we can see them in the exam. For the prep student, you must know all these. Very, very important. Our jab, our snap, our crackle, and our work now, our pour. Okay? These are further work now, further quantities or further derivatives of what now? Of position. Are you with me? So let's solve another question. Let's solve another question. So you can just pause the video and write this thing down. Let's solve another question. Another question. So, what is the dimension of force? So let me write the questions out. So solving it one by one. So the first one, force. Okay. Second one, we have pressure. Third one, we have power. So force. Second one, we have pressure. Okay. Then third one, we have power. The fourth one, we have density. Alright, so let us go. Just few of that more questions, okay? We are going to drop WhatsApp link under this video. So if you want to join us for tutorial, JUPEB student, JAMB student, you want comprehensive lecture, you want to have A in all your 3 papers, A 16 points for the JUPEB student. join us. All students, all the universities, are you with me now? You are from UNILAG, join us. UNIBEN, you join us. OAU, you join us. Other universities, OSU, LASU, UNIBEN, Nippon, all the universities that are doing what now, JUPEB, join us. And JAMB too, join us, okay, for comprehensive tutorials. Are you with me now? I'm going to drop what now? I'm going to drop a link, okay, a WhatsApp link under this video. You see a WhatsApp link under this video. Just click on the link and join us. Okay, are you with me? For JAMB students, what is for 300 above, okay, in your JAMB, join all. Okay, just click on the WhatsApp link and it will get into the what now? Into our WhatsApp, our private WhatsApp group for our what now? Students. So let us continue. So the first one, we have force. And I told you, if I want to get dimension, I must know the what now? The unit. Now, force is not a what? Fundamental unit. See another thing. If the quantity given is not a fundamental unit, okay, we go to the mathematical definition of the quantity. Are you with me? You know, force is not under what now? Under this word, under the fundamental unit. Force is a derived unit. So if you want to get the what now, the dimension, we must first go back to the what now, to the fundamental mathematical definition of what? Of force. So what is force? Mathematically, force is equal to what now? Product of mass. That's what now? Times acceleration. Mass is what now? Acceleration. Are you with me now? No. What is mass? Unit now. Unit. So mass is what now? The symbol is what? Kg. Acceleration is what now? Meters per second what now? Square. So what now is the dimension of force? Dimension of force will be equal to kg is capital letter what? L. Are you with me? Then small m is capital letter what? L. Then small s is capital letter what now? T. So I have t raised to power what now? Minus 2. So I want to write this, but I have to write this. What is the power of this m? I have m raised to power what? 1. What is the power of this L? L raised to power what now? 1. And what is the power of this T? T raised to power what now? Minus 2. So the dimension is what now? 1, 1, and minus 2 for force. We are going to do that. Everything. Why did I do like this? Because force is a derived quantity. It's not a fundamental quantity. So I will have to get the what now? Mathematical definition. Okay, let's go to what now? Pressure. Pressure is not a fundamental what now? Quantity. So I will go to what now? Mathematical definition of what now? Of pressure. So pressure. What is quantity? Quantity is what? Is pressure. Pressure. Okay. What is the mathematical definition of pressure? Pressure is just what now? Force by into what now? Area. Force over area is what now? Is pressure. What is force? No, force is also what now? It's not a fundamental what now? Quantity. I have to break this one two down. And we've done that. Mass and what? Acceleration. So this one will become mass times what now? Acceleration. See, I want to break it down. You must break it down. Break it down. Okay? For what dimension? Break it down. The right unit, you must break them down. They're all over what now? All over area. What is the symbol for this mass? Kg. So we have kg. Okay? Acceleration is what now? Meters per second what now? Square. All over. Area is meter square. Area is meter square. So I have area here. I have meter square here. That is meter square. So what will I do? Now, 1 meter here will cancel 1 meter here. 1 meter here will cancel 1 meter. If I have meter all over meter times meter, that's the meaning. I have meter here. I have meter times meter. Meter times meter is what now? Meter square. So this meter will cancel what now? This meter will now be left to what now? 1 meter down. So this one will become kg. Second minus 2 all over what now? All over here. Are you with me? I've cancelled 1 meter here. This meter will cancel 1 meter here. Let's work now. 1 meter. Now from the law of indices, this one can go up. When it goes up, it becomes what now? Minus 1. Remember this law. If I have a raised to power minus x, our answer will be equal to what now? 1 over what? A raised to power of x. Let me break this thing down so I can understand very well. Look at this. Look at this. This one here. This one here. Similar saying kg raised to power what? Second raised to power what? Minus 2 times all over what now? All over meter. What I have here, same thing. Once I multiply this one by 1, I will see how this thing will work. So I'll now apply law of indices here. So if it's going up, don't what now? Minus. So it's going up, don't what now? Minus 1. Now I have kg m minus 1, second what now? Minus 2. So what now is dimension? For kg, I have what? M. For meter, I have t is for minus 1. Then for what? For second, I have t is for what now? Minus 2. So if I want to write this, I can say m raised to power what now? 1. L raised to power what now? Minus 1. T raised to power what now? Minus 2. For the dimension of what? Or power. Let's just write all this thing down. So pressure. Let's just write them down, please. Let's write them down. So we need them. Let's write them somewhere. So for force is what? M raised to power 1, L raised to power 1, T raised to power 1, minus 2. Then for pressure is M raised to power 1, L raised to power minus 1, T raised to power what now? Minus 2. Let us go for what now? For power. Permission to write the thing off. Alright, so let's go. Power. So let me write the side off. Now, power. Okay. What is the mathematical definition of power? Energy. For what? For time. Power is what now? The rate of doing work. What energy is the capacity to do work? Energy is the capacity to do work. Power is the rate of doing work. Anytime you hear rate, this is what? With time, all over time. Are you with me now? So, what is energy? Energy is the capacity to do work, isn't it? And work is done when a ball moves through a distance. So this one here, I will further break this energy down to what now? Work done. So I have work done all over what now? All over time. And we said work is done when force moves through a distance. So we have force and what now? Times distance. All over what now? All over time. So we are getting there. We are getting there. So what's the next thing here? What's the next thing? So force, is the what now? Mass. Let me break it down further. Mass times what? Acceleration. Then times what now? Distance again. So I have distance. We get there. Don't give my beats. We need to rush. Then all over what now? All over our time. Let's put our time. Okay, let's just put our time here. Our time. So let's go. kg, isn't it? Meters per second square. What's inch of distance? Meters. Then all over. What's inch of work? Time. What now? Seconds. I want this thing to go up. Now look at this. I have 2m here. M is power 1. From the law of indices, when I have what now? The same base. A is power x times A is power y. The same base. Different powers. And I have what now? Multiplication in between them. What will I do? I will take one of the bases and I will add their what now? Power. So here I'm having m is power 1. What will I do? I will take one m. I will add 1 and 1. So I'm having kg m is power 1 plus 1. Second is power now minus 2. This one will now go up, do something similar. So when it's going to become what now? Times second is power now minus 1. Okay? The same thing again. I will add this one. I'm having kg m is power now 2. L is power now minus 2 minus 1. Now we are having finally kg m is power 2. L is power now minus what? Minus 3. So what is the dimension of what? Of power. Dimension of power will now be equal to kg m L is power 2. Then T is power now minus 3. So or finally we have L is carrying what? Power of 1. L is carrying power of what? Of 2. And T is carrying what now? Power of what? Of minus 3. So this is the dimension of what now? Of power. So write it here. Power. What's the dimension of power? We have what? M is power what? M is power 1. L is power 2. T is power minus 3. So for power. So we don't force, we don't pressure, We don't work with our power. And the last one is density. Density is not a fundamental quantity. In most of these cases, what they will give us in the exam are derived quantities. Okay, so you must know their mathematical definition, which I'm trying to explain here. Now, the last one is what we call density. Density. What is density? Density is what now? Mass over volume. Mass per unit volume. Mass over volume. Okay, so it's very straightforward. What is mass? Kg over unit of volume is what now? Meter cube. Meter cube. So on that go up, we have kg meter is per what now? Minus. When it's going up, change to what? To minus. What's that dimension of dimension? What dimension of dimension? That will not be what now? N. L is per what now? Minus what? Minus 3. You know, things missing. Why is things missing? Because it has power of what? Is 0. So I can finally write this one like this. M is power 1. L is power what now? Minus 3. Or T is power what now? Is 0. You can have like this or like this. In the exam, options, you want to give me, can either give me like this or like this. So what is the dimension of what? Of density. Density will give us what now? M is power 1, L is power minus 3, and T is power 1, T raised to power 0. So let's go to what we call principle of homogeneity. Principle of homogeneity. Just pause the video and write all these things down. Okay? So we are moving to what we call principle of homogeneity. Next one on the data is what we call principle of homogeneity. Principle of homogeneity. Principle of homogeneity. So we have principle of homogeneity. Principle of homogeneity. So, principle of homogeneity. The principle of homogeneity says that what? Says that okay, the dimensions of each of the terms of a dimensional equation should be the same on both sides. This thing is very interesting. We are going to use this one to discover many things under what now? Under dimension. So the first one is use of dimension. This is first. We can use dimension to know the exact form of a physical equation. That's the first one. We can also use dimension to know whether a physical equation is correct or not. Look at this. From this principle, we are going to discover many things. What's the first one? To determine or to know whether a physical equation is correct or not. Then the second one, we can use to know now to determine the exact form. The exact form of a physical equation. Physical what? Equation. So I'm going to solve question on this too. But the question should be what now? JUPEB questions. So the first one, I want to use dimension, principle of what now? Or homogeneity to solve this question. Look at the question. The question says what now? In the equation, this is the JUPEB question. The first question, let me confirm the year. The year is coming. I want to confirm the year. The JUPEB question 2022. Okay, it is Unilag mock examination. 2021, 2022. The question says the equation p raised to power x, b raised to power y, t raised to power z equals constant. Is Boyle's law. If, okay, so it means we have to find what now? Find the value of x, Find the value of y and find the value of what now? Of z. What is the Boyle's law? Boyle's law shows the relationship between pressure and volume. Are you with me? He said this thing should be a constant and should work now. Boyle's law. So I must first state Boyle's law first. Okay? So from this Boyle's law, I'm now able to establish this relationship. Are you with me now? So let's go to Boyle's law. Pressure and volume. Boyle's is pressure and volume. Charge is volume and what now? Temperature. Are you with me? So let's go. So for Boyle's law is this. Boyle's law, I have this. Pressure based inversely as what now? As volume. But you can have volume based inversely as what now? As pressure. The same thing. So from here, we have P. We remove this sign of what now? Proportionality to become what? The constant. Equals to what now? K over what now? All over B. We cross multiply. We are having V. This equals to what now? Constant. You see it? The other is P S power S, B S power Y, S power Z is a constant. And here we have PV. Because what now? So it means C is missing. Why is C missing? But that power what? Is 0. Anything raised to power 0 is what? Is 1. If that thing is not is 0. Are you with me? So yeah, I will now rewrite this thing as what now? P raised to power 1, V raised to power 1, T raised to power what now? 0 raised to what now? A constant. Look at this. I'm not comparing and contrast. P raised to power X, P raised to power 1. So this is our S. Let me just write it out so you understand what I'm trying to say. So P raised to power X, B raised to power Y, T raised to power Z equals to P raised to power 1, B raised to power 1, T raised to power what now? So what's our S? Our S is what now? Compared to the calculus power, S is 1, Y is 1, then Z is what now? Is 0. This is unique question. Okay, the amount exam 2021, 2022. We use this principle of homogeneity. Because this says what now? They must have the same thing. Each time must have the same thing on. Are you with me now? Are you with me? So what is that? So that's another question. Just another question. Another question. Look at this. God says the dimension, okay, of force. What is the dimension of force? This. Then I give us something like this. Give us something like this. Let me write some up. Write this one down. Okay. So the dimension of force. The dimension of force. This is question. The dimension of force. Because question. The dimension of force. The dimension of force. Of force. Now put in bracket, Newton is dimensionally equivalent to x power x, x power y, x power z. Find the values of x, y, and z. This should be the unit of force. The unit of force, Newton, is dimensionally equivalent to this. Find the values of x, y, and z. We're going to use dimension to solve this. So how do we do that? Let's do our solution. So the first thing I write it out, we're given unit of force. Okay, the size is what now? Is Newton. Okay, that's what they are given. They're given that unit of force is Newton. But force itself is what now? MA. Isn't it? So what is the normal unit of force? Okay, we have kg meters per what now? Per second square. Isn't it? So what is the dimension of the force, man? The dimension of force is what now? From what we have here, we have there m raised to power 1, isn't it? L raised to power what now? 1. Then t raised to power what now? Minus what? Minus 2. That said, this is dimensionally equivalent to this one. It means our what now? Our dimension m raised to power 1. L power 1, T raised to power what? Minus 2 is equivalent to what now? L raised to power x, L raised to power what now? Y, T raised to power what now? Z. So what's that value of x, y, and z? You just compare and contrast. 1 here, s is what? S is what? 1. Y is what? 1. And our z is what now? Minus what? Minus what? 2. Is this one clear? So that's another question. Another question. More questions. If you want more, just click that WhatsApp link and join us. Click the WhatsApp link, and once you have 100 students, the group will what now close. Make sure you be the first word now to click the link and join the WhatsApp. Are you with me? So God bless you as you join. Look at this JUPEB question again. It said if M raised to power A, S power B, T power C is the dimension formula of force. Find 2A minus B minus C. Find 2A minus B minus C. Let me write this one up. If M raised to power A, that's what they said. Now what is M raised to power A? If M raised to power A, S power B. If M raised to power A, if M raised to power A, S power B, T power C is the dimensional formula. Dimensional formula of force. Come on. We have to find 2A minus B minus C. This is the JUPEB question 2020-2021 about 5. This is the JUPEB question. The JUPEB question, okay, 2021, question number 5. If this is the dimensional formula of what? Of force. We have to find 2A minus B minus C. And what is force? See the dimension of force. M raised to power 1, S power 1, T raised to power what? Minus 2. So I'll just equate these. So I'm having M raised to power A, S power B, T raised to power C is equals to the dimension of force is M raised to power 1, S power 1, T raised to power minus 2. So for contrast, our A is what? 1, our B is 1, our C is what now? Minus 2. So what's that 2A minus B minus C? That will be 2 brackets. Our A is what? 1, comma, minus. Our B is what? 1, minus. Our C is what now? Minus 2. So we have 2 times 1, 2 minus 1. Minus times 1 is what now? Is plus. Okay, up plus 2. So we now having this 2 plus this 3 is 4. 4 minus 1 is what now? Is 3. So the correct answer is what? And also we have 8 minus 4, 3 and 6. That's option. 8 minus 4. 6 and what? And 3. So the answer is what now? Is 3. So is 3. So that's that on what? On that. Okay. Let us see how to use what now? Dimension to know whether a physical equation is correct or not. That question was JUPEB question. JUPEB question theory 2019. JUPEB question 2019. I'll read the question out and you see what is happening. 2019 JUPEB question. Okay, how to use dimension to know whether a physical equation is correct or not. Okay, so that is JUPEB question 2019 theory. JUPEB question 2019 theory number 1. So that is the question. Let's say the first one. We have to state the units and dimension of the following quantities. We have to state the units, and what now? Dimension. Okay? Go and check the question. That's why I have to write it down. Or 1, surface tension. 2, frequency. First one, surface tension. And 2, frequency. State unit and dimension of that. And the three percent show that the expression b squared equals to what now? B naught squared plus 2as is dimensionally correct. Okay? So we want to use what now? Dimension to know whether a physical equation is correct or not. See the result. This one you can just do that. Surface tension is what now? Force over what? Over length. I'm giving you the formula. So go and get the unit and what? And dimension. What is frequency? Per second. Okay? It should be in hertz, but per second. That frequency can be what now? In hertz. H-E-R-T-Z, hertz, or per second. What per second? Are you with me? For frequency. So surface tension is what? Force over length. Force per unit length. So go and do that. Get the units and get the what now? The dimension. Just give me the what now? The answer. Drop your answer in what now? In the comment what? In the box below. Are you with me? So let's go to this. I want to use dimension to determine whether this equation is what is correct or not. Now let me sand the going to you, please. In dimension, you can only add or combine quantities that are similar. So once you add them together, these are similar, they are the same. And you can also give another question that you will see to prove what I just said now. So I'll just say B equals to this one, solve it separately, or I'll say this one equals to what? This, solve it separately. That's when we solve it. We won't add everything. Okay, because principle of homogeneity says each term on both sides will work now the same. Okay, each term, this is a term, this is a term, this is another term. This is a constant, but we neglect it. Are you with me now? So the first one, to show whether this thing is correct or not. Final velocity, initial velocity, acceleration, distance. Okay, so our final velocity is going to work now in meter per second. Meter per second, that's the velocity. B not 2, we're going to work now, meter per what now, per second. Acceleration, what's the unit? Meter per second what now, square. This distance is going to work now in meter. So let us confirm. The first one to show, I will say B squared equals to what now? B not squared. That's that. So for the first one, either this. So to show that it's correct dimensionally. So what is the unit of velocity? Meter per second. All squared equals to velocity 2 meter per second. Meter per second. All what now? All squared. So open the bracket. Under this valve, AB raised to power x. It means this power here will affect A, it also affect what now? B. Open the bracket. So that will be A raised to power x, B raised to power what now? X. So open this bracket. These two will affect M. These two will affect what now? Minus 1. Are you with me? You have that. And mind you, this one is what? Is 1 here before. So 2 times 1 half, M raised to power what now? 2, M raised to power what now? Minus what? Minus 2. It's equals to what? M raised to power what now? 2, M raised to power what now? So what is the dimension? M raised to power 2, T raised to power what now? Minus what? Minus 2 equals to what? M raised to power 2, T raised to power what now? Minus 2. They are, this one, they are the same thing. X power 2, T raised to power minus 2, X power 2, T raised to power minus 2, they are the same thing. That's the first thing. Or, this thing again equals to this. This is a constant. I won't use that. I can just say B squared equals to what now? AS. I must have the same thing. Okay? Because this is one of the what now? Equations of motion with constant what? Acceleration. You know, straight line. If you associated what now? Bodies. This is one of them. So I want to use the method to show that it is correct. Let us go to class. What is it of what now? Velocity. Meter per second. I have all squared is equals to acceleration is what now? Meters per second what? Squared. Then times what's the unit of what now? Distance is what now? Is meters. So I'm having 2 of these. I want to be the area. Okay? Under law of what now? This is power 1. I'll add them together. I'm now having ms minus 1 2 equals to what now? M 1 plus 1 is equal to what now? Minus 2. So open this bracket. We have m raised power 2 x power what now? Minus 2 equals to what? X power 2 x power what now? Minus 2. So what's the dimension? L squared t x power what now? Minus 2 is equals to what now? L squared t x power what now? Minus 2. So it means this equation is dimensionally correct. This is JUPEB question 2019 number 1. Okay? So it means you cannot escape question under dimension. You cannot. Are you with me? So let us have another question. Let's have another question. Under what dimension? So I have like 2 more questions or 3 more questions to be solved. And can call it what now? Today. Okay? So please join the WhatsApp group. We have the link down below. Subscribe to the YouTube channel. Click the red subscribe button. Okay? And give this video a like. Okay? The more like you give this video, the more YouTube will work now. Will pop it out to more students. Okay? We have millions of students that will see this thing. Please give us a like on the video so that YouTube can work now. Recommend the videos to other students. Click the red subscribe button and join the WhatsApp group. I'm going to drop a link, okay, in the description below. I'm going to drop the link. Just click on the link to take you out to the WhatsApp group. Okay, so look at this question. JUPEB 2016 number 25. JUPEB 2016 number 25. I'm just having a JUPEB question because we are doing JUPEB work now, videos. Although JAMB can work now, can take advantage of work because we have dimension to work in JAMB. We have dimension in JAMB. Okay, so you can take advantage of what? Or so look at this. JUPEB question. JUPEB question 2016 number 25. JUPEB 2016 what? 25. Now look at this one. It said in Van der Waals equation. In Van der Waals equation. In Van der Waals equation. Van der Waals equation. The equation was given as what now? As P plus A all over B squared. Okay. B minus B equals to what now? R what? RT. This is the equation given. P plus A all over B squared bracket B minus B equals to what now? RT. P is the pressure. B is the volume. R is what now? Gas constant. T is what now? Temperature. We are not asked to what now? To find the dimension of what? A and B. Find the dimension of what? A and B. Find the dimension of A and what? And B. I recap. P is the pressure. P is the pressure. P is the pressure. Then V is the volume. V is the volume. Okay. Then this R is the gas constant. Gas constant. Gas constant. And T is the temperature. Temperature. Okay. All I have to find is just what now? The dimension of both A and B. Class. I said you can only combine quantities that are dimensionally what now? Similar. They are the same. So for them to have combined A all over B squared with B, it means this expression of T is what? Is pressure. Are you with me? Then for them to have combined B with this volume, it means this between is what now? Is volume. You can combine what now? Dimensionally terms that are similar. So how will I answer this question? Very simple. Very simple. Now look at this. Look at this class. I hope I'm not too fast, please. I'm trying to take everything in one video. Look at this video. So alright, so look at this now. Since this A over B squared was combined with what now? P. It means A over B squared equals to what now? Equals to what? P. So for the first one, solution. We say P is equal to what now? A all over B squared. So I'm now going to multiply. When we going to multiply, we have what now? A equals to what now? P B squared. What is P? P is pressure. What is the dimension of pressure? We have M raised power 1. We saw that one before. S power minus 1. Then T raised power minus 2. Then times. This is volume. V is volume. Volume. Unit is what now? Unit of volume is meter cube. What is the dimension of volume? S power 3. Are you with me? This one come. We have volume raised power now 2. This is power. So now we are doing what now? S power 3. And the power now 2. This is the volume here. S power 3. This is the power outside 2. Are you with me? So I'll multiply everything. So we have M power what? 1. S power minus 1. 3 power what? Minus 2. Then times 2 times 3 give us 6. So I have M power what now? It's power 6. So that's combined. I have M power what? 1. Minus 1 plus 6. That will be S power minus 1 plus 6. And 3 power what? Minus 2. So this one becomes what? M power 1. S power 5. Then 3 power what now? Minus 2. So this is the dimension for what? Our A. What about our B? Because B is combined with what now? Volume. It means volume also what? Because of B. Like I told you, we can only combine terms if they are dimensionally what now? Similar or alike. So this second one now, our B is equal to B or B equals to B. B equals to what now? B. Okay? And what is the B? B is volume. It means B equals to what? What is the unit of volume? M power now 3. So our B equals to what? What's the division? That would be n raised to the power of 3. Therefore, our A is what? M raised to the power 1, S to the power 5, S to the power 2, and B is what now? N raised to the power N raised to the power 3. So let us solve the last question. Okay, so more questions. Join the group for more questions. Okay, just click the what? The WhatsApp link below this video to join the group. And again, subscribe to our channel, okay, and like the video so that YouTube will work. We recommend it to work with more students. Okay, we have plenty of students that are doing JUPEB and JAMB. All of them will see this video. So you're going to help us, okay, to like the video so that YouTube will recommend it to more students. So the last one for today is a JAMB question 2. Now says the speed v. Let me write this one down. The speed v. Okay, the speed v. The speed v of a liquid leaving a tube depends on leaving a tube depends on the change in pressure. That P, change in pressure, and the density. And what? The density. Density what? Rho. This is symbol for density. Okay? Of the liquid. That's it. The speed is given by the equation. The speed is given by the equation. What's the equation? Given by this equation, V equals to K open bracket that P all over density. Okay, raised power now N. We have to find where K is a constant that has no unit. What's the value of N? Said K is a constant. Said K is a constant. Is a constant that has no unit. So, what is the value of N? What is the value of N? What's the value of what? Of N. So, we have to find the value of what? Of N. So, that's what we want to do for the last question. Okay, now look at this. So, how to solve this question? Let me write it up. This is JUPEB question 2016. Yeah, 2016. Oh, sorry, 2020-21, number 4. 2020-21, number 4. One question 2020-21, number 4. One question 2020-21, number 4. That's the question I'm going to use to wrap this video up. Alright, so let's go. Constant, that's no effect. Constant has no effect. Are you with me? Constant will have what? No effect in the person or in the solution. So we have this. Alright. So they said V is what now? The speed. So I'll write it out 1 by 1. Speed is meter per second. Unit of V, look at me. Because what now? Meters per second. What again was given? Pressure was given. What's unit of pressure? Unit of pressure. What is unit? That is what now? First of all, what? First of all, area, isn't it? So that was what now? AG meters per second square. Then dot what now? Dot M raised to power what now? 2. So it's going up becomes what? Minus 2. So everything becomes what now? kg meters minus 1 seconds what? Minus 2. Okay, this is minus 2, this is 1. 1 minus 2 is what? It's minus 1. So this is unit of what now? Of pressure. Are you with me? Then the last one is what? Density. Unit of density equals to what now? Kg meter what now? Isn't it? Because we said density is what now? mass over what? Over volume, isn't it? Mass over volume. So kg, the meter is 14 to go up, comes out now, minus what now? Minus 3. So we are asked to find our what? Our n. So let us change everything here. So let's confirm kg, meter per second square, then minus 2. Yeah, so we're good to go. Now my b equals to, just like this one will work now. It won't have any effect. Okay, so change the pressure, all over what? All over density is for what? It's for n. Are you with me? So what are b here? B is meters per second. That's that equals to pressure is kg, meters is for minus 1, seconds for what? Minus 2. Then all over density is what now? Kg, meters per what? Minus 3. And everything is for what? This for n. Are you with me? So let's go. Kg will cancel what now? Kg. Now meters, seconds for minus 1 is equals to meters for minus 1, seconds for what? Minus 2. This one is minus before. It will now go up. It will go up now. Plus. Are you with me? So we have m is for what now? M is for 3. So everything is for what now? This for n. This one now, m is for this. Meter, seconds for minus 1 equals to what now? M is for minus 1. Then plus 3. Seconds for what now? Minus 2. What now? N. So now having m is for minus 1 is equals to m minus 1 plus 3 to give us 2. Okay, then we have seconds for what? Minus what? Minus 2. And what now? I told you, love indices. This m will affect this. This m also affect what now? This now m is for minus 1 is equals to what now? M is for 2n, n times 2, 2n. Minus 2 times n is what now? Minus 2n. So I can now take any one that I like and compare and contrast. I can either say for m now, for m all out, for m wow, m is power 1 equals to what now? M is power what now? 2n. You can use this. Or for s, anyone want to use? For s, wow, s is power minus 1 equals to what now? S is power what? Minus 2 what? Minus 2n. So we equate their powers. Law of indices, the same base, different powers. We equate their powers. And this is having 1 equals to what now? 2n. What's the next thing? The divide this by what? By 2. By 2. By 2. Our n equals to what now? 1 2. If you use this one 2, you're having minus 1 equals to what now? Minus 2n. By minus 2. Minus 2. So our n equals to what now? Anyone to what? 2. You have the same. I'm very happy, okay, to have taken you so far to this extent. I'm very happy equally for you to have watched this video to this work, to this extent to the end. So it means you are what? You are done. So more questions in the group. I told you, make sure you subscribe to our YouTube channel. Click the what? Press subscribe button, like the video, and join our WhatsApp group. Okay? Join our WhatsApp. Our name is what now? Noticer. Noticer is our name. Noticer is our name. Noticer. And you can call any of these numbers. You can call any of these numbers. Any of these numbers. You can call any of these numbers. Okay, for inquiry. But make sure you join the what? The group. It's very, very important. I don't need to join the number. Just join the group. Okay? I have a group there. Group. Once you join the group, you will see all the things. More topics under physics, chemistry, math, biology. Say the name of the world. God bless you. Bye bye.